Okay. SD-WAN.
मिक्स चलेगा मिक्स.
This meeting is being recorded.
Okay. So SD-WAN, right? So before coming to any technology, why SD-WAN came into the market? First of all, we need to understand. Why I'm saying, because already we have the setup where we have the router, switches, firewall. Everything is working fine, no problem. Then why we have the requirement to have the SD-WAN in our network or our infrastructure? Why do we need SD-WAN? It means there was some disadvantage into the traditional network, means where we use the router, switch, firewall. Then only SD-WAN came into the market. So with the traditional network, right? Okay, if I draw a line here, this is our traditional network. And SD-WAN. So in the traditional network, actually, we use the devices like router, switch, firewall, WLC, AP. Multiple devices are there that we use into the traditional network, and this complete, like these devices complete the entire network. Entire network means basically our network is divided into three parts: DC, WAN, and LAN. If the organization is having DC for data center, LAN for campus network, and WAN for routing purpose, then our network or setup will get completed. And for these all the sites, be it any DC, WAN, LAN, we use the router, switch, firewall, WLC, APs, right? Other servers. We also use the servers, load balancer. Multiple network devices are there. So these are working fine. There were no challenges with that. The challenges came when organization started adopting the cloud feature. Application aware routing. Then, like when the organization or the vendor started shifting their infrastructure over the cloud, then it was seen that our traditional network, where we have the router, switch, firewall, WLC, these are not capable to connect with cloud. Or in the second way, we can say that the SD-WAN or any technology along with the cloud that came up into the market along with the cloud. So people started thinking that let's not build our data center and let's not build our own infrastructure. Let's come to the infrastructure where things are ready. We don't need to do anything, no need to do setup. We just have to get the services, pay for them, and adopt that. So if I talk about any branch office, if I have the branch office here, where we'll get the router and switch, but this router was not capable to interact with the cloud. Cloud means like nowadays AWS, Google Cloud,
GCP, AWS,
and
Azure.
Azure. Yes, multiples are there in the market, and these devices are not capable to interact with them. It means these are the problem with the traditional network. So problems are the very common problem with the traditional network are the first is cloud awareness. Second is security, or I would say fragmented security. The first is the organization, the current setup was not ready to adopt cloud awareness feature. Fragmented security means if you have a branch office, to provide the security at a particular branch, you have to have the firewall as well. Router is still very costly, and for each branch, if you are going for the firewall, that would put additional cost to the organization. And also, if you're going with the firewall, then also you need to have the IPS and IDS to provide the extra security. So the fragmented security, where you need to get the each and every box, firewall, IPS, IDS, load balancer. But from the deployment point of view, it's not very easy, or not, it's not feasible solution that you can go for the firewall feature at each and every branch, because that will increase the cost. Limited application awareness. Router switches are not understanding the application language. They were talking at the layer 3, means at the IP. They were not talking about the what, because router doesn't know what is this UDP, TCP, or any application like DNS, DHCP. They don't know what is the DHCP, DNS. They know the IP address behind that. So they are not ready to adopt those things, and limited. They are not aware about the application. What is the application? Over, like if I talk about the DNS or DHCP, so that is the application. But router was not capable to understand that this is the DNS service or this is the DHCP service. Fourth, high cost. High cost that we already discussed. Like if you have a branch office where you need to provide the routing feature, security feature, then you need to put the firewall. And if you go for the firewall, that will definitely increase the cost. Insufficient bandwidth. Insufficient bandwidth means if a branch office is having 2 routers, and this is connected with the ISP1, ISP2. So we were using our single link ISP1. This ISP2 was not utilized. If you want to use this thing, then you need to have the BGP configuration. That is also a complex BGP configuration. And to manage the complex solution, we need to have the expert level of the expert knowledge of the BGP, right? That means complex operation. If you have the 2 router, at the time you will only use the one single link. You are paying lakhs of the rupees for this link, and for this link also you are paying a lakhs of the rupees, but you are not utilizing this link. It means unnecessary, there is a burden to the organization in terms of the cost. So to avail this link, what you can do, you can use the BGP. That is also advanced BGP, where you can put the prefix. For some prefix traffic would go via this link, and some prefix traffic would go via R2. And for that purpose, you need to have the engineer with the strong BGP knowledge. That means complex operation. What else? Disjoint solution. Disjoint solution means if you are running a, let's suppose you have a branch office where you are running a MPLS. Tomorrow you have the requirement that I don't want MPLS because the cost of the MPLS is very high. I need the internet link. So the conversion from MPLS to internet is not possible within a day. It's not possible. You have to reach out to the respective ISP and ask them to convert this link from MPLS to internet, and that will take, in sometimes it will take 15 days, even 1 month also. But in case of, so that is the challenge, means disjoint solution. If you want to have internet, if you want to, okay, MPLS to internet, or if you want to, if you don't want MPLS and internet, you want the LTE link. Now we have the 5G. An operator claiming that you will get the 30 times faster speed as compared to the 4G. If over the 4G, if you are getting 4 MB link, that means 120 MB you will get over the 5G. If you are getting a 120 MB speed over the 5G, then why would I go for the internet and why would I go for the MPLS? Instead of this thing, I can simply put the 5G SIM here on my router. So the current scenario, the current router which we have is not ready to adopt the LTE feature. And that is very cheap solution as compared to the MPLS and internet. So these are the challenges, numbers of challenges are there, but these are the common challenges with the traditional network. That is why SD-WAN came into the market. It's not like that no one thought about this. No one thought about SD-WAN, or no one thought about the SDN technology. So, so these are the challenges, or you can say the drawbacks are trying to solve into the SD-WAN. So before coming to the SD-WAN, let's dig into the traditional network a little bit more. In the traditional network, where you have the router, it's not router, but let's consider it as a router, where you have the router, switches, and firewall. So this entire hardware was divided into 3 parts. The first part is management plane. Second is control plane. Third is data plane. This is, I am talking the traditional network, router, switches, firewall. So the hardware which we have from the Cisco or any vendor, that is basically combination of 3 things. management plane, control plane, and data plane. Management plane is to manage the devices. It could be monitoring, syslog, SNMP. Control means routing. Means if I have a one router here, another router, if they want to communicate with each other, or if I want to run any routing protocol, dynamic routing protocol, any dynamic routing protocol, for that purpose, we need to have the control plane reserved in router. Similarly, management plane reserved into router or network device for monitoring and syslog and SNMP purpose. Similarly, data plane. The data plane basically we use to forward the customer data. Data communication. It means if you have the router here, another router, PC, PC1, PC2. So now if a PC1 wants to communicate with PC2, traffic will go to the router, and from there next router, and from there PC2. So for this type of communication, control plane is used in the network devices, right? So consider this thing, remember this thing, and now let's come to the SD-WAN. So SD-WAN, before coming to the SD-WAN, there was a technology called SDN. Software-Defined Network. This is the parent of SD-WAN. So from this SDN, software-defined network, three things came into the picture. The first is ACI, second is SDA, third is SD-WAN. So you can say that SD-WAN came from SDN technology, and SDN technology that has the different flavor like ACI that we use for data center, SDA, software defined access. This is the application centric infrastructure. This is the software defined access that this technology we use into the campus network. Campus network means it could be anything, your branch office, your data center, not to the ACI one, not to the Nexus one. Data center, like in the data center, if you have the small branch office, a small NOC there where engineers are sitting, campus, branch office, remote office. This comes under the SDA network. Then SDN is for WAN. So at the beginning, if you remember, I told you if you have the DC, WAN, and LAN, then your organization is completed. Now, if you see here, SD-WAN, it has the ACI. Okay, SDN, it has the ACI, SDA, and SD-WAN. That means Cisco is having end-to-end package. If you want to have a ACI, you can have the Cisco. If you want to have the technology for campus, you have the SDA. If you want to have the technology for your WAN connectivity, you have the SD-WAN router. So it means Cisco has all the package. You cannot survive with the Cisco like nowadays we cannot survive with the internet, or we cannot survive with the mobile. Similarly, if you are into a networking field, so you cannot survive with the Cisco. That is why we always say Cisco is a smart company. Cisco is a smart company not because of this. Cisco is a smart company. Why? Because if every new technology is coming into the market, that is not part of the Cisco. If any vendor, Cisco will understand the technology and Cisco will acquire the company. This SD-WAN, it is acquired from Viptela. The parent company was Viptela. But here is also history. The person who invented the Viptela, he was the ex-Cisco employee. They started, they built their own company, and this Viptela was started getting the popularity. Then Cisco came into the picture. They say, now come to me. And Cisco acquired this company Viptela. After that, it is started calling as a Cisco Viptela. SD-WAN. That is why I'm saying Cisco is not a smart company. Cisco is a smart company not because of their technology. Cisco is smart company because of the technology and because of the acquisition. If you try to recall the Cisco history, Cisco is having their own router. Apart from that, all the, like most of the thing, it's not like that all the things, but most of the thing they have acquired from different vendors. If I talk about the firewall, there is a vendor pick and the Viptela, and DNS security, that is also from the different vendor. Source guard something, source guard or something, some different organization was there. So the point here is very simple. If you want to be into the networking, you have to live, you have to eat Cisco, you have to drink Cisco, and even in your dream also Cisco should come. Okay, so that is why Cisco is very smart company. Okay, so in our class, yeah,
क्या था पिक्स किसके लिए क्या
which one?
पिक्स था ना पिक्स क्या
हाँ,
किसके लिए एक्वायर हुआ था
Pix, actually this Pix na, it was a vendor from Nokia.
ओके
तो इनिशियली
फायरवॉल बनाती थी ना।
हाँ, पहले ये फायरवॉल बनाती थी, ठीक है। तो सिस्को ने क्या किया, इस कंपनी को एक्वायर किया, पिक्स को, ठीक है। तो उन्होंने फिर स्टार्ट किया सिस्को एस से। इससे पहले ये पिक्स कहलाती थी और दैट वाज द डिफरेंट वेंडर। जब इसने सिस्को ने इसको एक्वायर किया, देन दे केम अप इन द मार्केट विद द सिस्को एस से, दैट इज आल्सो जोन बेस्ड फायरवॉल। तो जोन बेस्ड फायरवॉल को जो इन्वेंशन है वो सिस्को ने किया था, ठीक है।
ओके
Okay, so that is not our content. Our content is SD-WAN. Okay, so let's come to the SD-WAN. Now SD-WAN, okay, like the SD-WAN technology came out of the traditional network itself. So if you remember, just now we have discussed there are 3 planes, not the aeroplane to go to the Dubai, Qatar to see the FIFA World Cup. The plane are control plane, the router or network devices resources are divided into 3 parts. This is very important. I'm drawing once again because already we have discussed, but this is very important. So this is divided into 3 parts. ठीक है. So this is the management plane. This is the control plane and data plane. अब टेक्नोलॉजी नई है तो नाम भी तो नया ही रहेगा ना, क्योंकि अगर ओल्ड टेक्नोलॉजी पे जाएंगे, अगर पुराना ही नाम देंगे तो पीपल विल नॉट entertain those things. They will think, okay, it's a similar technology. So here they have given a name vManage, and the function of the management plane and the vManage are same. Here also from the vManage, from the management plane, what we do the monitoring, and from vManage also we do the monitoring. And the control plane, they have given a name as a vSmart. Data plane, they have given as a name vEdge. So before coming to this these resources, what we have here, management plane, control plane, data plane, they were assembled into the same box. But into the SD-WAN architecture, they have segregated these things and they made a separate box, separate box, or separate application or hardware, or I can say as a software. So what they did actually, they said, okay, like if I have the solution, so what I can do, I can put my vManage somewhere in data center, I can put my vSmart somewhere in data center, and I can put the VAs at my branch office. Very simple thing actually. We have the multiple devices that, let's suppose the vManage is somewhere sitting into the USA, the vSmart somewhere sitting into the UK, or VA somewhere sitting into the APAC. But the question here is, how do they communicate with each other? I am saying into the SD-WAN, let's segregate the management plane, control plane, and data plane, and we are giving a specific name: vManage equal to management plane, vSmart equal to control plane, and data plane equal to VA. In the traditional network, all these things were part of the same box, but now here we have the different software or different box, and we are putting it in a different location. But the question here is, how do they communicate with each other? So for that purpose, they introduce another box that is called vBond. vBond means bonding between these guys. I need to have someone who knows about all the vManage, vSmart, and VH. So in SD-WAN, there are basically 4 components. The one is vManage, vSmart, so this is the first one, third one, third is vBond, fourth is VH. Okay. Now we are into the era where things are getting done, means automatically. Okay, let's suppose you want to open some anything. Let's assume you want to have the PAN card. What do you do? You go to the government site, click, done. Even nowadays also, if you download any application, we don't care whether it's asking to is asking to give the privilege to access your internal mobile photos or videos. We are just simply click done. So we are into the era where things are getting done automatically. So here also we need someone, or we need some application which can configure the device automatically. So for that purpose, they introduce another term. Fifth is RESTful API. This is the scripting platform. What does it mean? It means that if you want to configure the devices through the scripting, like Python, DevNet, you have to interact with these devices through RESTful API. So basically, there are 5 components into the SD-WAN, Viptela SD-WAN. The first is vManage, vSmart, vBond, vEdge, and RESTful API that we use for the scripting purpose.
Yes. Fifth बताना है, REST for API दोबारा.
RESTful API ये हम यूज करते हैं for scripting purpose. If I want to configure the vManage, vSmart, vBond through the script, through the Python script. So ये बंदा जो रहता है ना, सबसे टॉप पे बैठा रहता है, and that RESTful API will interact with the vManage, or vManage, from the vManage will push all the configuration to vBond, vEdge and vSmart. ठीक है, no worries, आएगा, धीरे धीरे आएगा. ठीक है. So now RESTful API,
full API,
or you can also say REST API, no problem. Forget about the full. REST API. REST API. It's a vendor, third-party vendor. Right?
API application programming interface, no?
हाँ, application programming interface. ठीक है. तो अभी कंपोनेंट समझा? कंपोनेंट कौन कौन से होते हैं? ठीक है. Now components, there are vManage. The first is vManage, vSmart, then we'll put the vEdge here. vEdge1, vEdge2, vEdge3, vEdge4, and like these are the branch offices. I would say it's a branch 1, branch 2, branch 3, branch 4. And what is this? This is the data plane. Done. And the vSmart, that is the control plane. The vManage, that is management plane. अच्छा, ये Zoom है ना, that is not licensed actually, so it will like be disconnected in 1 minute. Then again we need to join this bridge. Okay. Now the vManage interact with vSmart. अब जो ब्रांच ऑफिस है, हमारा जो ब्रांच ऑफिस रहता है, वहां पे हम what we get the internet link. It could be MPLS, it could be internet or 4G, LTE or 5G. ठीक है. So let's consider that here is the cloud